Without further ado, let's get on to our next talk. Our next talk is all about how performant you can be. Rishi Jain from Unbxd.
Okay, perfect. Oh, this is not on. Check, check. Is it on? Can you guys hear me at the back? Awesome, cool. Well, thank you, Gautam, for the introduction. Yeah, test slide, so that's good. So, in the morning, Gautam spoke a little bit about why speaking at conferences is important and how it's like a feather in your profile when you do that. I heard a similar pep talk in 2014 from Gautam, and that little pep talk inspired me to give my first ever talk at RubyConfIndia. And it's been fun so far, and that's why I'm always very happy to come back to where I started this speaking journey from. RubyConfIndia is special, and I have lots of friends under one roof, so I can meet everybody in one day and make some new friends. So yeah, let me see. Okay. So a little bit about me. My name is Rishi Jain. I'm located in Bangalore. That's my Twitter handle, or X handle as we call it these days. You can connect with me there. I work at this company called Unbxd. I'm a senior software engineer there. Unbxd is a remote-first company based out of Philadelphia. We have a very diverse group of people coming from all kinds of backgrounds and countries. What do I do at Unbxd? Here's a nice summary of what I do at Unbxd and what Unbxd have to offer for our clients. Do reach out to me if you have interest in knowing about any of these things. One of our offerings is tune reports for your Ruby on Rails applications. We've partnered with Nate Berkopec to do the tune reports. Some of the information that I'm going to share today is also from my experience of doing these tune reports for various clients. Well, there's a couple of ways we give back to the community. First is by writing blogs. And you can read our blogs on different topics around Rails upgrades, about performance tuning, and the links mentioned here. We also maintain a few open source gems, Next Rails being the one which I contribute the most to. I spoke about it last year in my talk on Rails upgrades. Maybe some of you were there in that room. You can check our open source projects in the links here. I'm going to share this presentation later on Twitter so you can have access to all of the content. Okay, let's start the talk by saying Rails is slow. I'm sure you all have heard this. Or maybe a different version, that Rails does not scale. Well, I think this statement is incomplete. Rails is slow, and Rails does not scale when developers make expensive mistakes in the code and do not know where to look for such mistakes and how to fix them. This is what I try to break down in this talk. I try to give ways to find areas to improve the performance of your application, so your customers never say that your app is slow. Let's do a quick poll to get things going here. Raise your hands if you've heard or come across these things. Seen or found an N+1 query, or maybe fixed an N+1 query. Thank you. Thank you for the honesty. I'm sure we all have. Yeah, lots of hands for that one, as expected. Heard from your customers that the app has been running really slow for the past few days. Any show of hands? All right, some of you. Heard from your senior engineers or your DevOps team that the CPU utilization is very high, or the app consumes a lot of memory. Have you deployed something new? Do we know why it's happening? Well, congratulations. You all have been heard or been around things which have to do with Rails performance monitoring. But this is not it. There are a lot of misconceptions about Rails performance, and let's talk about them as well. The back-end, front-end fiasco. Sometimes, or a lot of times, the engineers writing back-end seem to assume, and assume being the keyword here, that their code works perfectly fine and is fast. It is the issue of rendering, and thus it falls under the front-end team's bucket. Meanwhile, the front-end team says, hey, we are just rendering whatever the API is sending us. How can we be slow? It's their APIs which are slow. They need to work on their logs and figure out what's making their API slow. I think this is really what is happening here, right? Another one, every time we hear something is slow, someone says, let's cache it. A classic mistake made often is assuming whatever is slow can be made fast by caching data. But there are times when it is not true. In fact, it can make things further slow. Maybe the data you're caching is changing too often, and now you have to invalidate the cache and load the cache again. Otherwise, you might show stale data. So you might end up doing more network requests than you were doing without caching. A very common one. Bigger hardwares or more hardware will not make your app fast. Think of it like this. Bigger highways will not make your cars any faster than what it is, right? Yes, it will accommodate more cars. In our scenario, it will accommodate more requests, but it will not make those requests any faster. Now that we have seen some of the misconceptions around it, let's also take a look in brief why we should even care about Rails performance monitoring at all. I'll give you not one, but 4 reasons why you should do it. Scalability, user experience, cost savings, and professional growth. I'm not going to delve into any of them as they are pretty self-explanatory, but still if you want to talk about it, come find me after the talk and we can talk about it. For now, let's look at different components of a Rails application. In any typical system, you'll have a front end, you'll have a back end, you'll have a database, and a server. Let's start, in this talk, I'll only focus on the back end. That's the time I have, right? So I'll try to focus on the back end, and if we have any time, we can touch upon other topics. To talk about back end, I've divided the talk in 4 different sections: APMs, profiling, benchmarking, and common mistakes. Let's start with APMs. When we talk about backend in the context of performance monitoring, the most important thing we need to know about are APM tools. Let's look at what is APM and what are these tools. APM is a process of using software tools and telemetry data to monitor the performance of business-critical applications. These tools are also called as APM tools. Let's look at some of the APM tools that you can use: New Relic, Datadog, Scout APM, and many more. These are not in any order of preference or anything. It just happens to come to my mind when I think about APM tools used for Ruby on Rails applications. But these tools can be scary to begin with. I can recall I was lost when I first logged in into one of them, and I was like, there's so many options there. How do I even begin with, right? What does these graphs mean after all? So I wanted to give you a brief overview of what all these tools can do for us, so it makes it easier for you to get started. Let's look at some of the metrics these tools provide that can provide us insights about our application. Request queuing, response times, top transactions, memory usage, and many more. Well, these are only a fraction of the metrics that these tools can give us access to. All of them provides insight about how our app is doing, resource utilization-wise, capacity-wise, user experience-wise. Let's look at some of these metrics individually and what kind of information they can give us. Request queuing, one of my personal favorite metric. It is basically a measure of how long your request has to wait before it gets picked up for processing by the app server. I'll repeat. It is the amount of time that a request must wait before being addressed. This is what a graph can look like for request queuing. The request queue time should be between 20 to 50 milliseconds. Anything over that is a sign that something is not right and the customers are not having the best of experience. Let's look at the next slide for a weird example. Look at this graph. We see a spike in request queue time up to 10,000 milliseconds. That's 10 seconds. Obviously, the user would be left frustrated if nothing happens for 10 seconds. The simple reason why request queue time shoots up is that all your existing servers are busy with other requests, and your request has to wait until a server is available to work on that one. So it is directly related to resource allocation. If the request queue time is constantly under 20 milliseconds, then it is an indication that maybe you are over-provisioned and you should look at reducing the resources. When you're adding more servers, you're typically reducing the request queue time. You're not making your requests faster. APMs also give us a list of top slowest transactions of your web application. We can arrange them by their average P95, P99 response times, sort by different parameters like throughput. When you're trying to improve the performance of the app, this gives you a quick insight into which endpoints are critical, that is, receive the most traffic, and which are slow. So you can fix the issues with the slower endpoints. You can even drill down further for more information about specific endpoints. You can get information around what all stages the request actually went through, how much time it spent in each step, and you can get metrics around what queries were fired and how much time each query took. So if there's a query that is slow, and let's say it spends 80% of your response time there, that means if you make that query faster, your API would naturally get faster. Object allocation. It also gives us insight about these. It is very easy in Ruby to not pay attention to the amount of objects we are creating. Typically, it should not go over 50,000 live objects at any time. Higher than this can lead to higher memory consumption and can lead to memory issues which are always hard to fix and debug. Let's look at a very common pattern in Rails application to understand object allocation. Look at this code. We're fetching all the products and looping through them to update an attribute. It looks pretty straightforward, but there's a problem. The problem lies in product.all. It will load all the products at once in memory. It will shoot up the memory usage of our application and thus affecting the application. How to fix this though? The solution is not to load all the products at once. Instead, use the findEach method to load them in batches and thus not creating objects without even realizing it. It is suggested to use the findEach method even when you just started the application. That means you don't have enough data in your database, so using all versus findEach will not really make any difference. But if you start with this approach, you'll not be dealing with memory issues as your app grows. This is another metric, which is really important, instance restarts. This directly gives you information about your instance restarts. Let's look at the next slide for a weird example. When you see that specific time in the middle of the graph where there's so many lines are crisscrossed, that is when so many of the instances restarted at a very specific time of the day. It is critical information to try and debug, like what happened during that specific time. You can look at memory utilization, CPU utilization, throughput, request queue, something that helps you draw an inference of what went down at the time. If you have a theory of what went wrong, APM with its data also helps you verify your theory and back it up. In most cases, almost all, when you have a theory but the data is not verifying it, the theory is most likely wrong. Now that we have seen what APMs can do for us, what kind of information they can provide us, it's time we add a profiling tool in our arsenal. And that is also our next section in this talk. This will help us figure out what is going on in the request and where does it happen in your code. It's like an APM tool, but running on your application in your browser, and you can even run it locally. There are various gems which can help us profile our code in different manner. We're going to talk about just one of them, as I believe it just gets the job done. Rack Mini Profiler. After you set up the gem and run the app, this is what you'll start seeing, a little icon. In the top left corner of your screen, you can always customize it where you want. But when you click on that icon, it opens up a pop-up with a lot of information. It shows you the request. It also shows you what all steps it went through and time taken for each step. It even shows you the SQL queries fired during those events, just like what APM did for us. If you click on that SQL link, it shows you what SQL query was fired and which line triggered it. It is very helpful when you're trying to debug slow queries. Although sometimes finding what really triggered the query could be hard. And for that reason, there's an option to see the full backtrace and not just one line in the code. This is the option. Once you pass in the query patterns, you get to see a whole bunch of logs. Don't try to read this, it won't make sense. This is only to show you that, okay, you get a lot more information to look at, and you'll find your answer in these logs. It also gives you the option to get more information about page load events and how much time it's spent in each of them. Now, this is related to front end, but it's still important to understand that all of these steps, some of these steps we have control over and we can optimize it. Some of these steps we just can't. So it's always a good idea to know how much time we are spending while loading the page, and is there scope for optimizing it. As we said, like it's not just the back end, it's just the front end. It's usually the combination. While these are only a handful of features that we saw, there's a lot more that this gem can do. It can help us analyze memory. It can help us profile garbage collection, load flame graphs for our request. We can also choose which users we want to load the rack menu profiler for, as we would not want our customers to do the profiling for us on our production, right? This brings me to the next section of the talk, benchmarking. In performance, the next most important thing is benchmarking. If you think making a change will make your app faster, you have to prove it. And the only way to prove something is to measure the before and after metrics of the changes and check the results. And to do just that, there are a few gems that you can use. I'm only going to talk about one of them, but there are a few options out there. This is the gem that I'm going to talk about, Benchmark IPS. Some of you may already know that Benchmark is also a module which is part of Ruby. And then there's a gem called Benchmark IPS. There is some differences in each of them and how they work. We'll only be looking at the gem for now. Benchmark IPS. It will report the number of iterations per second for a given block of code. It uses standard deviation, which is a concept of statistics, as we know, to analyze the result. A higher standard deviation could indicate the results having too much variability. Let's look at an example. Take a few seconds to look at this code. Consider that we have the 3 different ways to loop this, and we're going to benchmark which is the best approach of the 3. This is how basically you benchmark using this gem. Let's look at the results when we run this code. It tells us how each of the code block did in iterations per second. It also indicates the standard deviation margin at the end of each result. In this case, there is not much difference in their iterations per second because the set is smaller and the 3 methods are not doing much in terms of how they perform. So let's look at another example with some significant difference in them. We have 2 methods defined here, a slower method and a faster method. Slow method is going to loop 100 times, while the fast one will run just once. Let's look at the results when we run the benchmark code. We can see that their iterations per second and their deviations as well. Here, since the difference between the 2 methods is huge in terms of how many iterations it can do per second, the deviation does not really matter. It matters when the difference in iterations per second is not too big. In this case, it won't really matter. This also brings me to the last section of the talk, common mistakes. Common mistakes, these are some of the common mistakes that I have firsthand seen in a lot of Rails applications that I worked on while fine-tuning their performance. All of these are listed here. Let's start with the first one. N+1 query, a lot of you had raised hands, some of you accepted that you've written these kind of queries. So it is a very relatable section. Let's look at the next slide for a simple example. Look at this query. What we're doing is we're finding all the posts and then printing the post title and the user's username. Looking at the logs, this database had 6 posts and it has fired 7 queries, a query to fetch all the posts and 6 other queries to fetch their individual users' information. This is okay for a small DB, but imagine this happening when it has, let's say, 10,000 posts. It would fire so many queries and the response of the API would naturally be slow. The fix is pretty simple. You might already know it. We need to eager load the user information, and now it just fires 2 queries. It won't matter if it has 6 posts or 10,000 posts. As simple as this is, we find N+1 queries all the time in Rails application that I've worked on. Now, these are simple N+1 queries that are also easy to fix. Let's look at some of the different ones. Consider this view code. We are looping through the post and rendering different partials based on a condition. Look at this line which says post.lots of comment question mark. We're calling this method for each post in the collection. Let's look at how this method is defined. This can seem all right at first glance, since we must have eager loaded the comments now. Only the problem is with the count method. It fires a database query to calculate the count. So even though the comments are eager loaded, there will still be a query fired for each post in the collection, as we're calling this method for each post. These kind of n+1 queries can be tricky to find in the logs. The fix, again, is very simple. You have to replace count with size. The way size works, it will not fire the database query to calculate the size. Small fix, but very easy to make this mistake if you don't know the difference between count and size, which can make your API really slow. Here's another example of an n+1 query. In this method, what we're trying to find is the first famous comment for the post. A famous comment is when it is liked by, let's say, more than 5 people. Now that we know of preloading the data, we can preload the comments for a post. There should not be an extra queries. Unfortunately, not. The problem is that the where clause does not really work well with preloaded data. So it will still go ahead and fire a fresh query every single time this is called. How to fix this though? There are a couple of ways. First is the Ruby way. We can preload all the comments and use the enumerables to do the manipulation for us. In this case, we can use the find method to find the first most famous comment via Ruby. This way we do not touch the database at all. But what if we had like lots of comments for each post? Would it still make sense to do the processing on Ruby? Because we'll be storing all these objects in memory, and after all, dealing with memory issues can be hard. Here's a second way. We can create an association with the conditions that we want. In this case, liked by people greater than 5, and then preload the association while loading the posts. This could be the most optimized way of doing this. This brings me to the second mistake, lack of background jobs. This is again so common in Rails applications. I've come across so many instances when a certain function that could have been done asynchronously was still done synchronously. Let's look at the next slide for an example. Imagine this code. There's a method called generate invoice and notify. As the name suggests, the method will generate the invoice for the customer and will send the notification to the customer at 3 different places. It will send an SMS, an email, and a WhatsApp message. Let's say it will use a third-party service to send an SMS. It will use SES to send email and a third-party service to send WhatsApp messages. And all of this is happening while the customer is waiting for the response on the screen. This is not the most optimal user experience. We should utilize background jobs more often. All of these notifications can be sent via a background job so that the customer does not wait on its screen, and a response can be very simple, that hey, you'll receive your invoice in your email or WhatsApp or whatever. But the customer should not wait on the screen for this kind of things. Which brings me to the third one, timeouts for third party, as we are speaking of third party. Consider the previous example. Imagine we were using some third-party service to send SMS notification to our customers. What if the SMS vendor is having their own issues with the system, and the request, which usually sends back the response in 200 milliseconds, is now timing out after a default wait of 60 seconds? That means our request will have to wait for 60 seconds to get the response back from the vendor that, hey, we have timed out and we don't really have a 200 response for you. And then we take some action based on that. Well, we should be stricter with timeouts when we're dependent on third party and not leave everything for default. Ideally, wait for a few seconds, maybe 2 seconds, but if you don't get the response in 2 seconds, handle that case explicitly. Maybe push a job that will re-trigger the process again after some time, or store an exception somewhere and deal with it later. But never wait for any vendor request for more than 2 seconds, and if you don't get the response, deal with it. It's always a good idea to stay in control of how long a request should wait for its response. And this is the final one and the last one in this section, missing DB indexes. All the time, believe me. There are 2 patterns to it. First, either the index is completely missing, or second, the index is present, but it's not being used in the queries. Let's look at an example. Consider this migration. We're creating a table called users, and we have 2 columns of our interest, name and email. And we fire a simple query. Our APMs have been telling us that even though this query looks very simple, we're finding the first user with a certain email, but APMs show us that, hey, this query is taking a lot of time. So naturally, we try to analyze it. So we run the explain command on it. The explain command will give us the query plan, for which it will tell us how the database is going to execute this query. Notice that it says seq scan, which basically means sequential scan over the whole table. So it will scan each row in the table and match the email. That is going to be very slow. Larger the table, the more time it will take. Also notice the cost. The cost is 2440. The next step is obviously to make this query faster. So we'll add an index on the table on the email column and then measure the change, because that's how you benchmark it. So let's run the explain on it again, and now notice the change in the query plan. It does not say sequential scan anymore. It says index scan using an index. And look at the cost, 8.44. It has come down from 2440 to 8.44. That is massive gain, just by adding a simple index. Missing indexes is a very common pattern. The next one is if you have an index, but you're not really utilizing it. That happens when either you're using the wrong order of index. Let's say you have created an index on multiple fields, and you're using a different order than what you've created on. So it won't use that index. And this brings me to the end of this talk. If you found this talk interesting, here are some of the resources that you can use to learn more about these things. The top one is Nate Bokopek's performance workshop and other materials that he provides. They're a great starting point for Rails performance. A book, couple of blogs that helped me in understanding all of these topics. And yeah, that's me. Thank you for the talk, being a great audience, and that's my handle. And reach out to me if you have any questions. Thank you.
We are running out of time, but I'm going to see if there is anyone questions. All right. Thank you so much for helping. There comes a question. So I'm going to give time for only one question, Rishi.
That's
Sorry.
great. Yeah.
Hi, have you considered using go deeper into any particularly slow, any?
We haven't heavily used Abdex Score. I think it's something that we monitor all the time in terms of are we improving the Abdex Score or not, but it's not our starting point. That's not where we start with, okay, our Abdex Score is coming as really slow, so let's start looking at why our app is not doing well, because Abdex Score is, I feel, basically a score how your user is having experience of your app, and it is always moving. Like, that's the variability about it. You can never have an Abdex score of, let's say, 80 and be happy about it. It always goes up, and you keep on improving it. So we haven't used that as a threshold for monitoring it, but we keep on observing it as we make changes to see, do we need to now change it and move it to a different level? That's what we've done. So it actually depends on the kind of application that you have, the kind of traffic you receive. So for example, if you receive millions of requests per second, and you have set an Abdex score of, let's say, 98, right? But what you really is at 70. It doesn't really do justice to your developers when you set a score of 98 and you're really below 98. So start with something which makes sense for your app. There's no standard answer to it that start with 70 or whatever. So it's something which is very specific to your app. Thank you.
All right, thank you so much, Rishi.